Hey, did you guys miss me? This is like the shortest video watching ever. Um, so far, I've hopefully been able to put everything together based on just prior knowledge. That was kind of the goal this week. So the only thing that you need from me, in addition that you couldn't just figure out on your own, is using a couple of different formulas. So you've been working a lot with the unit circle and um, and radians and degrees and all that stuff. So we want to apply some of this stuff now. And the application shows up in calculating the length of certain arcs and also the area of a sector. Okay, so inside of a sector. Now I want to clarify one thing. For some stupid reason, the textbook and a lot of sources use S to represent arc length, which is kind of confusing when we talk about sectors. But with arc length, it's a distance, right? So this is a distance, and we're measuring the arc. So from one point on the circle around the circle. Down here with area, okay, we're looking at the sector. Call it a sector. Basically, think of like a piece of pie or a piece of pizza. Okay, and like the space inside of it. So let's say we have, let's make up any old circle, and let's say we have like a 30-degree angle. Okay, so here's my positive x-axis, and we'll go here. So 30, okay, 30 degrees. So one thing that you need to know is that in both of these formulas, theta, okay, the angle, needs to be in radians, okay, because radian is talking about, remember, wrapping the radius around the circle, so it's a distance. It is not just an angle measurement, okay? It's literally saying for a 30-degree angle, it's this portion of the circle, okay? So the other thing that we need to know here is notice R, right? Now unit circles are easy because we know that that it's always 1, right? The radius is always 1. But for this, right, that radius can change. So let's say here maybe our radius is, I don't know, let's say 4, okay? So the radius is 4, we're dealing with a 30-degree angle. So if I want to know the length, I'm talking about this distance around the circle, okay? I want to know what that is. So first of all, I know the radius is 4, right? So 4 times, but again, instead of using 30, I don't want to use 30 because that's a degree measurement. I want the distance, right? So like the value on the unit circle that it's worth. So we're going to take, and we can use, actually I'll use this since most people have graphing calculators. So I want to take, actually we don't even need this, what am I thinking? 30 degrees, hopefully you just use your unit circle to help you with that, right? 30 degrees lines up with pi over 6. So I'm going to put pi over 6 for my theta. So this is going to be 4 pi over 6, or I could reduce it to 2 pi over 3. Now, we want to know a distance, right? That doesn't help me really understand what the distance is around that circle. So that's where we do want to use the calculator. Okay, so and you could type it in right back here, okay, but it's good practice to simplify. So I want to go 2 times pi, if I can find pi on here. Oh, I lost it. Oh, there it is. Pi, and divided by 3. And there is our answer. So I got 2.09. Final answers will round to the nearest hundredth, okay? And usually there's going to be some kind of measurement. Maybe this is inches, right? So this will be in inches. Okay, so that's our distance around that portion of the circle. Okay, and the other thing I want to point out too, think about circumference, right? It's 2 pi r. Well, 2 pi represents the radian measurement all the way around the circle, so it's really following the same exact formula, except that now we're only dealing with a smaller chunk of that circle. Now, area of the sector, we're going to use the same example, okay? So the same scenario, but now that 30-degree angle is making this sector. Okay, so I'm going to fill that thing in. So I want to know the area or the space inside of that region. Again, keep in mind, this is 30 degrees, which means that this portion on a unit circle is pi over 6. Okay, and then we're going to plug everything in. So we know it's 1/2 times the radius squared. Okay, so 4 squared, then times pi over 6. Well, 4 squared I know is 16. I'm going to do some of this work in my head just to speed up the calculation. So I know it's 16 pi, so remember that's over 1, and then 2 times 1 times 6 is 12. Okay, again, if I want to simplify further, I can before typing it in. And well, 16/12 can reduce to 4/3, so this would be 4 pi over 3, which will just make my calculating a little easier. So 4 times pi, and then divided by 3. And that is my answer. So I get 4.19. And again, this is area now, so we got to think about this being inches squared. And that would be it. The other connection I want you to make with this, think about pi r squared being the area of a circle. We're only talking about half now because keep in mind it's 2 pi all the way around. Half of that is here. And then pi over 6 means we're splitting up half of the circle into 6 pieces. So that's kind of where that comes from. You don't have to know that, but sometimes that might be helpful. So these are the formulas we're going to use for the next few slides. Towards the end, you're playing an awesome game of golf, Mario Golf, using these formulas. Hopefully you find some fun in that. I can't take credit for it. I found it somewhere else, and it was a full 9 holes. I shortened it just to 3 for you. But I think you'll have fun with it. So good luck the rest of the way. As always, please reach out if you have any questions.